Okay, good morning, children. In the last class, we had discussed about the preparation of this alcohols, right? Preparation of alcohols. Vidul, can you tell me any method of preparation of alcohol?
From alkenes.
From alkenes, through which method?
By acid catalyzed hydration.
Oh, yeah, acid catalyzed hydration. Then?
By carbonation and oxidation.
Is it carbonation?
Carboration.
No. Please check.
Hydrocarburation.
Hydroboration, not carbon there. Okay, hydroboration followed by oxidation. Okay, these are the two methods for the preparation of alcohol from alkenes. Then how can we convert this carbonyl compounds to alcohol? Dia, can you tell me any one method?
Reduction of aldehydes and
Yes, reduction of aldehydes and ketones using certain reducing agent, right? Then any other method? Emmanuel? Last one.
Carbolic acid and esters.
Yeah, okay. Carboxylic acid and ester using the same reduction. And what about Grignard reagent? Using Grignard reagent also, we can able to convert this carbonyl compounds to alcohol. Okay. So today we are going to learn about the preparation of phenols. Preparation of phenols. So in the case of this phenol, it is also known as carbolic acid. Okay, phenol is also known as carbolic acid. In the earlier days, we are preparing this phenol from coal tar. Coal tar, that's the raw material for the preparation of this phenol. But nowadays, there are certain synthetic methods from which this phenol can be obtained. So now we are going to learn the different methods of preparation of phenol from certain synthetic compounds. So this phenol, it is also known as carbolic acid. Okay, it can be prepared from coal tar in ancient days. Coal tar. And we are learning the 4 methods of preparation of phenols in this section. First one from haloarenes. Second one, benzene sulfonic acid through alkaline hydrolysis. Then the third one is hydrolysis of benzene diazonium salt. And the fourth one from Cumin. So there are 4 methods of preparation of phenol. What about the structure of phenol? How can we draw the structure? Sania, can you tell me? What about the structure of phenol? Yes. Which group is present there? Unmute. Which one? Tell me. Yeah, aromatic ring. Then to make it phenol, which functional group is present? OH, right? This one is phenol. So this phenol is also known as carboxylic acid. It can be prepared from coal tar in ancient days. And nowadays we prepare phenol from the 4 synthetic compounds. First one is haloarene. Second one is benzene sulfonic acid. Third one, hydrolysis of benzene diazonium salt. And the fourth method from Cumin. Okay. Shall I move to next slide? Children, have you completed?
Yes, ma'am.
Okay. So here the first method is from haloarenes. What is haloarene? An aromatic ring with one halogen. Here the example is chlorobenzene. Chlorobenzene. So this chlorobenzene, it is treated with sodium hydroxide, NaOH, at 623 Kelvin temperature and 300 atm pressure. Chlorobenzene, it is treated with sodium hydroxide at 623 Kelvin temperature and 300 atm pressure. And here you can see instead of chlorine, O minus Na plus is substituted, right? This one is known as sodium phenoxide ion. Sodium phenoxide ion. Okay, sodium phenoxide ion. Then after this formation of sodium phenoxide ion, acidification take place. Okay, acidification take place. That means we add acid and it will become converted to phenol. So it's a simple reaction from haloarenes. Here the chlorobenzene is treated with sodium hydroxide at 623 Kelvin temperature and 300 atm pressure. It is converted to sodium phenoxide ion. Okay, then through the acidification of the sodium phenoxide ion, phenol will be obtained. This is the method of preparation of phenol from haloarenes. This is clear? If you learn this chemical equation of this reaction, you can able to write the chemical equation in the form of sentence, right? If you know the names of each compounds, it will be easy. Here you can see one aromatic ring with chlorine. It is chlorobenzene. Then the another reagent is NaOH. So this chlorobenzene is treated with sodium hydroxide at 623 Kelvin temperature and 300 atm pressure. One ion is formed. Okay, that is sodium phenoxide ion. And on the further acidification, this phenol will be obtained. That's the first reaction, first method of preparation of phenol. This is clear, children? First method, all of you?
Yes, ma'am.
Yes. Then the second one, it's from benzene sulfonic acid. Benzene sulfonic acid. So from benzene sulfonic acid, first we have to prepare benzene sulfonic acid. Then it will be converted to phenol. So the first step, this one is benzene. A 6-membered ring with alternate double bonds, right? Benzene is treated with oleum. Do you know the chemical formula of oleum? Anyone? Oleum. No? It's H2S2O7. H2S2O7. That is oleum. So this benzene, it is treated with oleum and benzene sulfonic acid is obtained. A benzene ring with SO3H group. This one is known as benzene sulfonic acid. Benzene sulfonic acid. Okay, benzene sulfonic acid. Then again it is treated with sodium hydroxide and acidification take place. So when this NaOH is added to benzene sulfonic acid, here the same sodium phenoxide ion is formed, but it is not represented in this chemical equation. Here in this arrow, you can see two reagents, right? First one NaOH and the second one is H+. All of you please look here. In the second arrow, you can see the two reagents, NaOH and H+, right? And the final product is right here, it is phenol. So first the sodium benzene sulfonic acid, it will react with NaOH and sodium phenoxide ion is formed, similar to that of previous step. Okay, when benzene sulfonic acid react with sodium hydroxide, sodium phenoxide ion is formed. Then again on acidification of sodium phenoxide ion, phenol will be obtained. So here the two steps are included in one step. That's here the two reagents are represented in the same arrow. Actually this step is like this. SO3H. Then it's reacted with NaOH. So the sodium phenoxide ion is formed, O minus Na plus. That is sodium phenoxide ion. Then again with acid, it will be phenol. Okay, this is the actual reaction take place there. But the two steps are included in one step itself. Clear, children? First, the benzene, it is reacted with oleum to form benzene sulfonic acid. Then this benzene sulfonic acid react with sodium hydroxide to form sodium phenoxide ion. Then again on acidification of the sodium phenoxide ion to form phenol. The two reagents, they are included in the same step. Okay, so you should already understood that from the reaction of NaOH with benzene sulfonic acid, sodium phenoxide ion is formed. Then after the acidification of sodium phenoxide ion, phenol is formed. Yeah, Achud, ask me.
Ma'am, can you explain the after the second, like the last step again?
Yeah. After the formation of benzene sulfonic acid, it will react with NaOH. Here the first reagent is NaOH, right? So here the sodium phenoxide ion is formed. This is the actual process take place there after the first step. Okay, this benzene sulfonic acid reacted with NaOH. Again, the sodium phenoxide ion is formed, similar to that of previous reaction. Okay, then again on acidification of the sodium phenoxide ion, phenol will be obtained. Here this step is included there, but it is not represented in the reaction. That's it. Can you please read this portion from the textbook, page number 332. After from benzene sulfonic acid, then it will be more clear. Achud, can you read?
Benzene from benzene sulfonic acid.
Hmm.
Benzene is sulfonated with oleum and benzene sulfonic acid so formed is converted to sodium phenoxide on heating with molten sodium hydroxide.
Yeah.
Acidification of the sodium salt gives phenol.
This is clear now. So these are the steps taken here in the preparation of phenol from benzene sulfonic acid. Okay, first one it's from haloarene and the second one it's from benzene sulfonic acid. This is clear, children? Any doubt, anyone?
Ma'am,
Yeah.
here what is the one we're calling as sodium phenoxide?
This one benzene ring with O minus Na plus. I told you that it's not included in the reaction, but the two reagents are added here in the second step. So we should understood that already sodium phenoxide ion is formed and it is converted to phenol. Okay, yes, that's it. This is clear for you, children, everyone? Please switch on your videos. Shall I move to next methods? Please respond.
Yes, ma'am.
Okay. Then the next one, it's from diazonium salt. Do you remember this diazonium salt? We already learned one reaction related to diazonium salt. What's its name? That's in the preparation of haloarenes. Anyone? What's the name of the reaction that related with diazonium salt? The previous chapter. Srihari, can you tell me? Srihari. All of you switch on your videos. Punya, can you tell me? What's the name of that reaction related to this one, diazonium salt? It's a named reaction. Preparation of haloarenes. Anyone? Yes. Just the named reaction that comes under haloarenes. Yeah, Gauri, that's it. Tell me.
Sandmeyer's.
Yeah, it's Sandmeyer's reaction. Okay. That's the preparation of haloarenes, right? It's also from amines. So here also it's from diazonium salt. So first method, that's to prepare diazonium salt. Then again it is converted to phenol. So for preparing this diazonium salt, we take aniline. It's the primary aromatic amine. Okay, primary aromatic amine. It is known as aniline, primary aromatic amine. That is aniline. A benzene ring with NH2 group. That is aniline. It is reacted with NaNO2 and HCl. NaNO2 and HCl. This one together known as nitrous acid. NaNO2 plus HCl. It is together known as nitrous acid. NaNO2 plus HCl. So this is the reagent. And the diazonium salt is formed. This benzene diazonium chloride, this one is known as diazonium salt. Diazonium salt. Benzene diazonium chloride. So the primary aromatic amine, that is aniline, it is treated with nitrous acid. The mixture of NaNO2 and HCl is known as nitrous acid. Then benzene diazonium chloride is formed. It is known as diazonium salt. Then here water is added. Hydration take place and the phenol will be obtained. Instead of N2 plus Cl minus, here OH is replaced the position. So this is the method of preparation of phenol from diazonium salt. When primary aromatic amine, that is aniline, it is treated with nitrous acid. It's a mixture of NaNO2 and HCl. Benzene diazonium chloride is obtained. That one is, 1 minute children. Yes, benzene diazonium chloride is obtained, that is diazonium salt. Then again water molecule is added to form phenol. The side products are HCl and N2. Any doubt? Anyone?
No, ma'am.
Okay. So this is the third method of preparation of phenol from diazonium salt. Then the last method, that is from cumin. Okay, from cumin. Here this is the structure of cumin. One benzene ring with isopropyl group. This one is isopropyl. So this isopropyl benzene, it is known as cumin. You can write the cumin, that is isopropyl benzene. Isopropyl benzene. Here there is one propane group and the middle carbon that is substituted by this benzene, right? That's why it is isopropyl benzene. Isopropyl benzene. Its common name is cumin. IUPAC name isopropyl benzene. Or you can also, this isopropyl benzene also considered as the common name. We can also number it in the form of IUPAC name. Okay, it's a form of hydrocarbon, isopropyl benzene. Its common name is cumin. So the first step, cumin is oxidized. Okay, cumin is oxidized in the presence of air. Cumin is oxidized in the presence of air and cumin hydroperoxide is formed. Here in this reaction, you can see that instead of here two oxygen atoms are added to this reaction, right? To this cumin, 2 oxygen atoms are added. Oxidation means addition of oxygen, right? So here the 2 oxygen atoms are added to this cumin and it will be cumin hydroperoxide. Cumin hydroperoxide. Okay. Then water is added in the presence of acid to form phenol and acetone. Here one more important product will be obtained, that is acetone. Along with phenol, acetone is also formed. So this is considered as the worldwide production of phenol is from cumin. Okay, this method is more preferred for the industrial preparation. So this phenol is mostly prepared from this cumin in industries. And here one more thing, acetone is also formed along with cumin. Acetone is also an important organic compound, right? So using the same reagent cumin, the two important synthetic compound can be generated from this method. This is clear? Cumin, that is isopropyl benzene, then it is oxidized in the presence of air. Two oxygen atoms are added to its structure, then it will become cumin hydroperoxide. Then water molecule is added in the presence of acid to form phenol and acetone. Phenol and acetone. Both are industrially important synthetic compounds. And this method is used for the production of phenol in almost all laboratories or factories. Any doubt, children? The preparation of phenol from cumin. All of you, please switch on your videos. This is clear? Dia, can you please read the description about the preparation of phenol from diazonium salts?
A diazonium salt is formed by treating an aromatic primary amine with nitrous acid NaNO2 plus HCl at 273 to 278 Kelvin.
Yeah.
Diazonium salts are hydrolyzed to phenols by warming it with water or by treating with dilute acids.
Okay. Then, Naurin, can you please read the description about the preparation of phenol from cumin?
Phenol is manufactured from the hydrocarbon cumin. Cumin or isopropyl benzene is oxidized in the presence of air to cumin hydroperoxide. It is converted to phenol and acetone by treating it with dilute acid.
Yeah.
Acetone, a byproduct of this reaction, is also obtained in large quantities by this method.
Okay. So these are the 4 methods of preparation of phenol. This is clear, children? First one, it's from haloarenes. Then it's second one, actually it's from benzene sulfonic acid. But before that, we have to prepare this benzene sulfonic acid from benzene. Okay. Then the third method, it's from diazonium salt. Here also, first we have to prepare diazonium salt. Then it will be converted to phenol. Then the last method, that's from cumin. It's the industrially preferred method because both the products are useful, acetone and phenol. Clear? This is clear for you?
Yes, ma'am.
All of you? Yes, right? Okay, then. Yes, yes.
The second method of preparation.
Michael, yeah? Last
Ma'am.
method. You're asking about the industrially important method, right?
No, the second method, ma'am.
Want to explain again?
Just to write it down.
Yeah, it's from benzene sulfonic acid. This one, right?
Yeah.
Okay.
Okay, ma'am.
Completed?
Yes.
Okay. So that's about the preparation of phenols from different substances, different synthetically important substances. Then we are moving to the physical properties. Okay, physical properties of alcohols and phenols. And which are the 2 parts contained in this alcohol and phenol? Alcohol and phenol. In alcohol, there is one alkyl group, then plus alcohol, right? Or OH group. And in the case of phenol, there is one aryl group, then plus alcohol, that is OH. In the case of alcohol, alkyl group plus OH group, and in the case of phenol, aryl group plus alcohol, that is OH group. So in the case of both these alcohols and phenols, this OH group, this alcohol part, that's the reason for their physical and chemical properties. Okay. OH group is responsible for all the properties of alcohols and phenols. Yes. And what's the name of this OH group? Alcoholic group, otherwise hydroxyl group. Okay. OH group is otherwise known as hydroxyl group. Then first we can discuss about the boiling point. Yes. Physical properties of alcohols and phenols. First one is boiling point. Boiling point. And the boiling points of alcohols and phenols increase with increase in the number of carbon atoms. Okay. Boiling points of alcohols and phenols, it will increase with increase in the number of carbon atom. If there is long chain of carbon atom exists, their boiling point increased along with the increase in the number of carbon atoms. So in the case of alcohols, this boiling points will decrease with the increase of branching. This boiling point will increase with the increase of number of carbon atom if it is in the straight form. Okay. In the case of alcohol, if more branching occurs in the straight chain, this boiling point will decreases. So there are 2 points. In the first case, if the number of carbon atoms increases, the boiling points of alcohols and phenols increases. And the second point is that if branching increases in this alcohols, the boiling point decreases. Clear? Here the reason is that increase in van der Waals force. Okay, the first one here, increase in van der Waals force with increase in number of carbon atom. And the second one, due to this branching, this van der Waals force will decreases. Decrease in van der Waals force. Okay. This first point, the boiling point of alcohols and phenols increase with increase in the number of carbon atoms. This is due to the increase in van der Waals force. And the second one, in alcohol, the boiling points decrease with increase of branching in carbon chain. This is due to the decrease in van der Waals force, because due to the decrease in surface area. When more branches will came, the surface area will decreases, right? So here the van der Waals force also decreases. Yes. And here you can see, is this image clear for you, children? Yes or no?
Yes, ma'am.
Yes. So first one, that's about alcohol. And the second one, that's about phenol. Okay, this one is an alcohol group. Okay, first one, ROH. It is considered as the first alcohol. And the second one is this one, ROH. Here you can see one dotted lines in between oxygen and hydrogen, right? Dotted lines you can see in between oxygen and hydrogen. What is this? Dotted line represents that exists between oxygen and hydrogen. The oxygen of one alcohol, that's between the hydrogen of another alcohol. So what is this dotted line?
Force.
Which type of force?
Van der Waals.
Van der Waals force.
But it's not in the case of same alcohol, right? One alcohol with another one. What type of bond exists between this hydrogen and oxygen? If there is hydrogen, Yeah, Gauri, once again.
Intermolecular force.
Which intermolecular force? Hydrogen is there. So which type of intermolecular force? Hydrogen can,
London force.
which one? Which type of bond between this hydrogen and the neighboring oxygen?
Hydrogen bond.
Intermolecular hydrogen bond. Okay. So here, when there is hydrogen and one electronegative atom, there will be definitely hydrogen bond formed. Okay. So here it's between two molecules. That's why it is intermolecular. Okay. Between two molecules. That's why it is known as intermolecular hydrogen bonding. So the dotted lines represents intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Oxygen of one alcohol, it's bonded with the hydrogen of another alcohol. In the case of phenol also same thing. This one is one phenol, this is another one. So the oxygen of the first phenol that is bonded with the hydrogen of second one. So here also intermolecular hydrogen bonding exists between both alcohols and phenols. Okay. So can you tell me, children, does this intermolecular hydrogen bonding have any effect on this alcohols and phenols? Their boiling point? Yes or no? What's your opinion? Does this intermolecular hydrogen bonding have any effect on boiling point? Yes. Tell me. Dia, what's your opinion?
Yes.
Yes, right? Achyut, what about you?
I forgot.
You can tell your opinion. Yes or no?
Yes.
Yes, right. So here in the case of this alcohols and phenols, they have higher boiling point compared to any other class of compounds. Okay. Boiling points of alcohols and phenols are higher in comparison to other classes of compounds. Other classes of compounds like hydrocarbons, ethers, then haloalkanes, haloarenes, these all comes under the organic compounds, right? So among this all organic compounds, this alcohols and phenols have higher boiling point. Okay, higher boiling point. And this higher boiling point, it is due to the presence of intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Here you can write the high boiling points of alcohols are mainly due to the presence of intermolecular hydrogen bonding in them. It is lacking in ethers and hydrocarbons. Okay, so higher boiling point of alcohols and phenols compared to other classes of compounds, that is due to the presence of intermolecular hydrogen bonding between the molecules of alcohol and phenol. Clear? Yes. Then here you can see a comparison between ethanol, methoxymethane and propane. They have almost same molecular mass, 46, 46, 44, right? Ethanol, methoxymethane, propane. First one that comes under the alcoholic group. Second one is comes under ether group, and the third one is a hydrocarbon, right? Ethanol is an example for alcohol. Alcohol. This one is ether because methoxymethane, oxygen group there. And the third one is one hydrocarbon. These three compounds have almost similar molecular mass. So we can compare with these three compounds. Then you look at the boiling point given here. In the case of ethanol, it is 351 Kelvin. 351 Kelvin. And in the case of methoxymethane, it is 248 Kelvin. And in the case of propane, it is 231 Kelvin. So here the maximum boiling point, it was shown by alcohol, right? And in the case of ether, the boiling point, it is intermediate between ethanol and propane, isn't it? The boiling points of methoxymethane is intermediate of the two boiling points. So here the main reason for the high boiling point of alcohol, it is due to the presence of intermolecular hydrogen bonding in them. It is lacking in ethers and hydrocarbons. So mainly you have to learn the 3 points. First one, if the number of carbon atom increases, boiling point increases. Okay, if branching increases, boiling point decreases. Then compared to other class of compounds, alcohols and phenols have higher boiling point. It is due to the presence of intermolecular hydrogen bonding. Clear? Yes, children?
Uh,
Yeah.
Ma'am, boiling point decrease with increasing carbon chains, but we are telling when carbon increases, boiling point increases, right?
Which one? Which one? Here the with increase in branching. Okay, when the carbon atoms increased in a straight chain, boiling point increases. Okay, if there is any branching occurs, it will be decreases because the surface area will decrease. That will affect the van der Waals force. There will be decrease in van der Waals force with decrease in surface area. Clear? This is clear about boiling point? All of you?
Yes, ma'am.
Yes, okay. Then the next one is about solubility. Solubility of this alcohols and phenols.
Can you show the previous page once, please?
Yes, this one, right?
Yes, ma'am.
Okay.
Okay, ma'am.
Yes. Then about solubility. In the case of solubility of alcohols and phenols in water, it is due to their ability to form hydrogen bonds with water molecules. In the case of alcohol, there is one OH group, ROH group, right? In the case of water molecule also H2O. So there will be chances for hydrogen bonding. So solubility of alcohols and phenols in water, it is due to their ability to form hydrogen bonds with water molecules. And this solubility will decreases with increase in the size of alkyl or aryl groups. If the carbon chain is very much longer, then the solubility will decreases because it's mainly based on the hydrogen bonding between alcoholic group and water, right? Because the hydrogen bond can exist only between OH group and H2O. If there is more alkyl or aryl group present, the solubility decreases. Okay. This is clear, children? And in the case of certain alcohols with lower molecular mass, okay, they are almost completely miscible in water. Miscible means completely dissolved in water. This is clear about the physical properties. Only two physical properties are explained here. First one is boiling point. Second one is solubility. So how can how can be the formation of this alcohol with water molecule, the bonding? Yeah, Achut, doubt?
Miscible means soluble, right?
Which one?
Miscible.
Miscible means soluble, yeah. It does not exist as two layers. Okay, in the case of kerosene and water, you can see it in the two layers. That is immiscible liquids. Here it is completely miscible. Okay. So here the bonding is like this, ROH. Then so there will be an intermolecular hydrogen bonding between the oxygen and the hydrogen. Okay. This is clear, children, about the preparation of phenols from different compounds and their physical properties. Yes or no? All of you switch on your videos. Yes, yes. Punya, Mehak, Rijas, Naurin, Michael, Srihari, all of you switch on. Okay, let me take your attendance. Just wait. Then we can discuss the remaining portion in the next class. Okay. All of you, please complete your project within this week itself. And those who are completed, you can send me the completed pages. Okay. Then thank you, children. See you in the next class. Bye.